Hello, pre-calculus students. So when I made the original video, I guess there was no sound. So what I'm going to do is I'm actually watching the video that I originally made with no sound. And then what I'm going to do is talk over that so you do have video, audio to help you out with the video because I want to help out those audio learners who are out there. So the first part is just we are graphing y is equal to the sine of x, and these graphs are periodic, and that means that the function values will repeat as x increases. So essentially, a periodic graph will have the exact same pattern over and over and over again. So the sine value of a function is equal to the y value of the corresponding point on the unit circle, and the cosine function is equal to the x value of the unit circle at a specific point. So before we move on and we draw that graph, I just want you to note, let's look at what's going on for that sine function. When our angle is 0 radians, the y value is 0, because this is sine of x is the y value. When we are at pi over 2 radians, the y value is 1. When we are at pi radians, the y value is 0. When we are at 3 pi over 2 radians, the y value is -1. And when we are at 2 pi radians, the y value goes back to 0. And then it's just a matter of drawing a very smooth line, which kind of represents what's happening to the y value on the unit circle as we go from 0 to 1, 1 to 0, 0 to -1, and -1 to 0. Now, the next part of when I fill in those notes, I'm going to be writing the domain. Now, in the domain, there's never going to be an input that's invalid. All values for the domain are going to be valid because you can just keep on going. Start at 0, -2 pi, -4 pi, -6 pi, -8 pi, -10 pi, going on forever. You can just keep on going around. And then positive values, you can go from 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. You can keep rotating around the unit circle and you'll be fine. The range, well, the lowest y value is -1 and the highest y value is 1. So the range is -1 to 1 inclusive. Our x-intercepts are going to be pi times k, comma 0, because our x-intercepts have a y value of 0, because remember, we do have input and output. And it's pi k, because k, that sign says k on the set of z, of all, k on the set of z, where z is all integers, 1, 0, -1, -2, 3, 4, 5, going all the way off into infinity. And the reason why I do that is because we have an x-intercept at here. We have an output of 0, then plus pi. We have an x-intercept here, so that's plus 1 pi. So let's look at it this way. When k is 0, our angle is 0, because pi times 0 is 0. And we know it's an x-intercept because it intercepts the x-axis and the output is 0. Then we do plus pi, so half circle rotation. X-intercept is 0. 2 pi, a full circle rotation, x value is 0. 3 pi, 1, 1, 2, 3. Still at x-intercept, 4 pi. And so you can see 4 pi, 5 pi, 6 pi, 7 pi. Look at my arrow and how for infinite values of pi going positive or in the positive direction or in the negative direction, that will give you an x-intercept, because an x-intercept is the value on the edge of the unit circle that will intercept the x-axis. And that's when y equals 0. The maximum is going to be here, the maximum point, and it's going to be the maximum at pi over 2, but then plus 2 pi k. So it's a maximum for each full circular rotation. So essentially, all angles coterminal with pi over 2 are a maximum. Same thing for minimum. All angles coterminal with 3 pi over 2 are a minimum. So it's 3 pi over 2, 7 pi over 2, 11 pi over 2. Oh, you could also go backwards. Negative pi over 2, negative 5 pi over 2, so on and so forth. It's continuous. It's bounded above. It's bounded below. So there's no break in it. It's continuous. It's bounded above. Highest y value is 1. Bounded below. Lowest y value is -1. And we have x-axis symmetry, which makes it odd. Remember, odd is f of negative x is equal to the negative f of x. F of negative x is equal to the negative f of x. Our key points: we have an intercept at 0, 0, a max at pi over 2, 1, an intercept at pi 0, a minimum at 3 pi over 2, -1, an intercept at 2 pi 0. So I'm just writing what the critical points are. Now, the graph of y is equal to the cosine of x. Once again, we're following the x-axis. So when theta is 0, our x value is 1. When theta is pi over 2, our x-axis is 0. When theta is pi, our x-axis is negative, x value is -1. When theta is 3 pi over 2, our x-axis is x value output is 0. And when theta is back to 2 pi, our x output is 1 again. So that's what draws the cosine graph. We're looking at the inputs as angles and the outputs on the unit circle. Now the domain is from -infinity to infinity. The range is from -1 to 1. The x-intercepts, so same. This is kind of the same logic as the sine graph. X-intercepts, the output is 0. I think about it at pi over 2 and pi. So think about it. This is a little bit weird, but here you have to flip the unit circle, rotate it 90 degrees, because the input, the x-axis for the cosine graph is the angle, and the output is the cosine value. So the x-intercept is when the output is 0. So the output is 0 at pi over 2, 3 pi over 2, and all angles coterminal with pi over 2 and 3 pi over 2. The y-intercept, when x is 0, y is 1. So y-intercept is 0, 1. Our maximum and minimum, just like the sine and cosine, are 1 and -1. And the maximum and minimum are at 1 and -1 at all angles coterminal with, at least for the maximum, all angles coterminal with 0 or 2 pi. And for the minimum, all angles coterminal with pi. Let's move here. The function is continuous, bounded above, bounded below, just like the sine function. It's even. The cosine function has symmetry across the y-axis. Remember, the symmetry, an even function says that f of -x is equal to f of x. That's y-axis symmetry. And just listed the critical values here: 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. All right. Now we're going to talk about amplitude. So amplitude affects the maximum and the minimum of the sine or cosine function. And what you do is you take your original output and then you multiply it by 2. So it's literally taking the sine of x multiplied by 2. That's what affects the amplitude. So here, our output is going to be 2 instead of 1. So we can look at this full screen here. So that value is 2. This value. So notice how the highest y value goes from 2 instead of 1, and that's because you have a 2 here. Now that negative sign is going to have a reflection across the x-axis, but the actual value of the amplitude is still going to increase by a factor of 2 as far as how much we have. You can actually think of this as a vertical stretch. Period. And yeah, let me just talk about amplitude a little bit more here before I go into period. So in both examples, the amplitude is 2. So the amplitude is equal to the absolute value. So the absolute value of negative 2 is 2. So you still have an amplitude of 2. That's the mathematics of it. Now with period, we've already established. So period is how often the pattern of the graph repeats. So with the sine of 2x, think about it. If you have 2 times the input, you're going to be going around the unit circle twice as fast. So that's actually going to be a horizontal compression. Now let's look at right here. So that means instead of having a period of 2 pi, because normally it takes us, we have a period of 2 pi because it takes us 2 pi radians to go across the entire circle. Here we're going to have a period of pi because we complete all the angles in the unit circle twice as fast when we have a 2 multiplying our input value. So here we complete the entire pattern of the sine graph twice as fast. So we complete the entire pattern from 0 to pi. The second pattern is going to be from pi to 2 pi, and you have the exact same pattern. So that's why I've labeled the red function. We can call that cycle 1 and cycle 2. How do I actually find the period algebraically? I take the term inside the parentheses and divide it by 2 pi by that, because you have original period of 2 pi if you don't change the sign function at all. 2 pi divided by 2 is pi, so that's the period. Graphing y is equal to the cosine of x over 2. 2 pi over 2, that's going to be equal to pi. That's going to be equal to 4 pi, because here the actual term inside the function is not x over 2, but you can think of it as 2 pi over 1/2, because that's x over 2. You could rewrite that as 1/2 times x. So 2 pi over 1/2 is equal to a 4 pi period. And so when you look at that period, so I take the entire cycle of the cosine function, I have to stretch it out over 4 pi radians instead of 2 pi radians. So you still have the same maximum midlines and intercepts, but you stretch it out a lot more. So the period is found by 2 pi over b. Whatever your coefficient is inside of the parentheses of a trig function, that's going to affect the period by altering it by 2 pi over b. 2 pi over b, that's what we have right there. So when b is greater than 1, think about dividing by a number larger than 1 will cause a horizontal compression, causing it to get smaller, and a number larger is going to, when b is a fraction, dividing by a fraction is going to allow your period to get larger. So that's a horizontal compression, horizontal shrink. This is a horizontal stretch. A phase shift. So a phase shift is just a shift left or right. So you just take the original sine graph and shift it here to the right pi. Here you take the cosine function and you shift it to the left pi. And you'll see me write those critical values and graph the function. And same thing for cosine function. I find the critical values and I graph the function. And so essentially I'm just making sure that I start with my original cosine function and I shift it. So remember, original cosine function starts at 0, 1 and shift it to the left pi. Here, start my original sine function and shift it to the right pi. Sorry, that's my phone going off. Now, in both examples, the phase shift is pi, and we can write it as a times the sine of bx minus c, or a times the cosine of bx minus c. The phase shift is found by c over b. If you think about it, you could also find the phase shift by factoring out b, because when you factor out b, you divide each side by c over b. When the argument is bx minus c, the phase shift should be to the... Oh, I guess I missed that on my original one, but that's fine. I can redo that now. So here I'm just showing how a vertical shift, that's going to alter the midline. So sorry, you'll see this right here. But here, going back to the video, when I have bx minus c, the phase shift will be to the right. This is just like horizontal shifts for transformations of functions. And when it's bx plus c, the phase shift will be to the left. Now, vertical shift of the midline. Here we just have sine of x plus 1. And so that shifts the midline up 1. And cosine of x minus 2, you shift the midline down 2. But you'd still, make sure you plot that function. This function would look like as such. And I'm drawing it methodically in real time there. So essentially that just shifts it down 2. So essentially shifting the function down 2, up 1. But you're shifting its midline, okay? So you're always shifting the midline of the function so the function stays centered. Now the last point I make is that you can also rewrite these as you can factor out the b if you really want to know what the phase shift is. So you can see a of sine of b to the x plus c minus d. So that's just showing that being factored out. So a times the sine of b factored out times x minus c plus d. That is the amplitude, and that's the video. All right. Have a great day. Hopefully this will have sound.